This video is all about the repository pattern. What is it, when to use it, and why is it so polarizing when it comes to storage in .NET? Hi everyone, Amichai here. I do have a quick disclaimer if you're new to the channel. So I am a Microsoft employee and these are Microsoft technologies that we're talking about, but I'm not talking on behalf of Microsoft. These are my personal opinions. Okay, so with that out of the way, let's continue. Okay, so what is the repository pattern? So Microsoft says repositories are classes or components that encapsulate the logic required to access data sources. So for Microsoft's definition, all a repository is an abstraction layer in which you hold all your data access logic. So you just call the interface or whatever abstraction that you have, and behind this abstraction sits your actual logic of querying the database, maybe filtering, and so on. Okay, what does Martin Fowler say? So Martin Fowler has a similar but a bit different definition. So basically he says that you have the data mapping layer and you have the domain layer, and the repository abstracts away the data mapping and the data access logic. Okay, so we'll look into that a bit later. If you're not familiar with domain-driven design, then don't worry. This is intended also for complete beginners in domain-driven design. So I will have sections here that I'm going to talk about specific terminologies from domain-driven design. So if you don't understand it, then don't worry. By the end of the series, you'll have a good understanding of these terms, and what I'm saying now will make a bit more sense, okay? So you can revisit this if this doesn't make sense at the moment. Okay, so let's look at an example. So this video is part of my series of building a REST API completely from scratch, following clean architecture and domain-driven design. But it's also a standalone video, so if you only want to learn about repositories and understand why this topic is so polarizing, then you can watch this video without other context. Okay, so what we have here is a dinner hosting system in which you have users. They can create dinners, so you can invite people to join your dinner, and people can confirm whether or not they're coming to the dinner that you created. Okay, it's sort of like Airbnb, where you have your home and you can turn it into a hotel. So here you can take your home and turn it into a restaurant. Okay, so let's look at an actual practical example of what this looks like. So don't worry if this looks a bit intimidating, I'll break it down. So what we have here is we have the create dinner command handler. Okay, so this is using the CQRS design pattern. And if you're not familiar with it, then all this is when a user wants to create a dinner in the system. So this piece of code over here is invoked. And what we have here is basically the user says, okay, I want to create this dinner. So first we want to make sure that the user exists. Then we want to actually create the dinner and store it in the database. Okay, so where does the repository pattern come into play here? Well, basically we have these two repositories where we abstract away the logic of getting the user and adding the dinner to the database. And for us, it's just simply calling a class as if it's sitting in memory, right? So let's look at what this repository interface looks like. Let's look specifically at the dinner repository. Okay, so let's say we have something like this. You have the iDinner repository, and it has some methods for accessing the dinners that are stored behind the scenes. Now, how is this implemented? And are we actually storing the dinners, or are we mapping it to a different object and then storing it in the database? We don't know. Okay, that's one of the beauties of this design pattern, where you don't care about this, right? So you can have an in-memory list implementation, where you basically have a list of dinners, and they are manipulated to satisfy the interface. But you can also be using Entity Framework Core and manipulate the DB context in order to satisfy the interface. Okay, so now that we have a better idea about what the repository pattern is and how it might be implemented, let's try to understand why is this so polarizing? Because if you're looking at this and you're saying, big whoop, this is pretty simple, right? It's pretty intuitive and obvious. Why is this even called a pattern? So let's dig into it and try to understand what's the story behind here. Okay, so let's look at it from a few perspectives. So first, let's look at it from the perspective of clean architecture. Okay, so in this series, this is the architecture of the final result of what we're going to be building. Over here, we have the create dinner command handler that we looked at now. And over here in the application layer, we have our dinner repository and the user repository over here, which follows one of the core concepts of clean architecture, which is let's have the inner layers define interfaces and the outer layers will define the implementation, which can be replaced with other implementations without the core logic needing to change. Okay, so as we would expect, over here in the infrastructure layer, we have the actual implementation of those interfaces. Okay, so if you're looking at this and you're saying, great, so it fits perfectly with clean architecture principles, let's actually go back to the example where we saw we're using Entity Framework Core to implement the repository. So if we look at this, this is the data access solution that we're using. What is this DB context? This is also an abstraction. So what's sitting behind this DB context? Who knows? It might be a document DB, it might be a relational DB, it might be an in-memory DB. We don't know, okay? And we don't care about what the implementation is, because that's the beauty of Entity Framework Core, that you can use different technologies and you have this layer of abstraction. So why should we add another layer of abstraction on top of this layer of abstraction? Isn't this just redundant and now we need to test more stuff? We have more logic that we need to maintain. So this thing over here, this is already an abstraction. We can take this and just use it where we want to access it. Okay, so that's a great case against it, and one of the reasons that many projects don't use the repository pattern and just simply use a DB context from Entity Framework Core, because it's already an abstraction. Okay, so let's look at it from the perspective of domain-driven design. Now, if you're not familiar with domain-driven design, this might not make a lot of sense, so you can skip to where we're actually going to be implementing the repository pattern. And if you want to get a sneak peek of what we're going to be talking about, then you can follow along. Okay, so from the perspective of domain-driven design, then let's go back to the create dinner command handler, right? So if you're looking at two of these methods over here, and you're saying this is actually much more readable than manipulating the DB context over here, and if you have the same logic repeated in multiple places in your system, then it makes a lot of sense to encapsulate it and put it in one place, not to repeat yourself multiple times. So yes, that makes sense. But if we're looking at it from the perspective of domain-driven design, then the repositories work with the aggregates. So that means that they store and load from the database the entire aggregate. Now over here in this example, this is a very straightforward example where we basically have the C of CRUD on the aggregate. So over here, it's pretty intuitive. We just add the aggregate and it makes sense over here. But let's look at an example where it doesn't really make sense, okay? So let's imagine that just like YouTube has this big view where you can see your subscriber count, you can see the live count. So let's imagine that this application has become a big thing, and there are big companies that are using it, and they're really excited to be hitting a specific number of confirmed guests. So what you might have if you're using the repository pattern over here, then you might say, okay, let's get the dinner that we're talking about, and let's get the count of the confirmed guests. If you're thinking to yourself, okay, this is great, then you might be forgetting that over here, we're loading the entire dinner. This entire logic can be encapsulated in a single query to the database, where you do the query directly on the data, and then you're not loading anything more than just an integer, right? So that's a good case. Now you might say, okay, I can fix this pretty easily. Here's the naive fix for it. I'll just create in my repository a method. Let's get the count of the confirmed dinner guests. I'll have this logic encapsulated behind my interface. So over there, I'll have it in a single SQL query, for example. Well, here's a little spoiler. This is going to be such a great feature that tomorrow you might want also the pending dinner guests and also the declined dinner guests. And then you'll see repositories which have so many methods that are just trying to optimize for the query to the database. And it becomes this God file of accessing the dinner, which can be just huge. Okay, now there are ways to go around this. So if you're familiar with the specifications pattern, then we can create a specification and pass a specification and have that implemented that way. And that's true. I'm not going to be talking about the specification pattern in this video. Maybe in the future, I'll make a specific specifications video that will dive deeper into specification and how it can be used and implemented, but that's not in the scope of this video. So if you're watching this video because you're searching for whether or not you want to use the repository pattern in your application, and you read multiple blogs and Stack Overflow discussions, and you're not sure what you want to do, then this is just a subset of the reasons from each side. There are many, many other reasons to why to use it or why not to use it, but there are some solutions. So if, like in our system, you're using CQRS to separate your commands from your queries, then you can, for example, use the repository pattern for the command side, because in the command side, we're manipulating data, and manipulation of data is always on the aggregate. So it makes sense that you'll load and store in the database the entire aggregate. And in the query side, you won't use the repository pattern. You'll just use a DB context, do whatever you want to do, join tables, pull the exact data that you want to do, and then you're not restricted by these rules of using only the aggregate. Okay, so that's one solution that you might do. But you might also say, my system is not going to be so complex. I prefer not having Entity Framework even referenced in my application or domain project. So I want to put everything behind this interface. It's easier for me to mock in unit tests. Then that's what I want to do. And you know that your system is not too complicated and this file won't become a God file. Then you might just use the repository pattern always, and that's it in your application, and that's completely fine. Okay, so that's it about the repository pattern. If you're bored and you're looking for something to do, then I highly encourage you to look at these discussions. It's just fascinating how passionate people are on either using it or not using it. Now, in the system that we're going to be building, we will be using the repository pattern, and that's because I want us to get familiar with it and see if it's right for your applications. So this project is only for educational purposes. I don't want you to take the repository pattern because we're using it here and use it in your applications. You need to make sure it makes sense for your scenario. Okay, so now that we have all of this out of the way, let's go ahead and implement the repository pattern in our application. So what we have is the register and login request, which arrive to the authentication controller, and from there to the authentication service in the application layer. And currently what we're doing, we're returning a Jwt token back to the user, and the user isn't persisted. It's not validated that the user actually exists when he tries to log in, nothing like that. That's what we're going to be doing today. So we're going to be creating the iUser repository interface, which will be implemented over here in the infrastructure layer, which will currently be implemented just as a static list of users. But in the final result, we're going to be using Entity Framework Core. So stay tuned if this sounds intriguing. Okay, and also we're going to be creating an intermediate implementation of the user entity in the domain layer. This will change multiple times in the upcoming videos. So this is just the implementation that we're going to be using for now. So when we get to that stage, then we'll talk about what our application is all about, how do we want to model our entities, what's the relationship between them, and so on. There's many, many topics to talk about. So just for now, this is the implementation that we're going to be using. Okay, so let's go ahead and implement the iUser repository interface and complete the register and the login flow, which will allow users to actually register and log in. Okay, so let's go ahead and do it.
The hoop is big after all.
Okay, so the first thing I want to do is actually go over here in docs, and we'll always keep here the domain models as their current state evolves. So let's have here domain models. And over here, let me paste the definition that we looked at before. Let's open it in the Markdown Preview Enhanced extension. Right, so this is what we looked at before. And I just put here a note. This is a disclaimer. Of course, this will change in the future. This is just, again, an intermediate implementation. Okay, so let's go ahead and model this. So in our domain, let's create a new folder. It's called Entities. And over here, let's create our user. Yes, actually, this looks good. Let's just fix the indentation here. Let's create here the last name, the email, and the password. Okay, now let's say that if we don't specify the ID, then this has a random new GUID. And because we have nullable reference types enabled, then let's just tell the compiler this ain't going to be null. Okay, so let's go ahead and over here in the interfaces, let's create a new folder. Let's call it persistence. And in here, let's create the iUser repository interface. Okay, now again, we have two things that we want to check when doing the login and the registration. One of them is fetching the user by his email address, and the other one is adding the new user. Okay, so let's add these methods. So iUser repository, and over here let's have yes add, and also let's have here get user by email, let's say. Okay, and basically what we have here is we specify the email, and then we might get a user and we might not get a user if he doesn't exist. And over here, we pass the user and add it to the storage. Okay, now again, we don't care about the implementation. We're in the application layer. We're just defining the interface. Let's go to the authentication service and inject it over here. So let's say private read-only iUser repository, user repository. Let's add it to the constructor. And here let's have our actual logic. Okay, so the first thing we want to do is validate the user doesn't exist, right? After we've validated the user doesn't exist, then we can create a new user, generate a unique ID, and persist, yes, the user to the database. Then we want to create the Jwt token and return it to the user. Okay, so let's start. So if now we want to check in the user repository if yes, let's say here is not null, then let's say for now let's just throw an exception. Okay, so throw new exception, user with given email already exists. Okay, next let's create the user. So let's say var user equals new user, and here yes, let's give it the values. Right, seems about right. Let's wrap it so it's more readable. Then let's persist it to the database. Yes. And now we can create the Jwt token. Over here, we no longer need to have this new GUID over here because it was generated as part of the creation of the user. Let's put this over here, and that's it. Okay, for a login, what we want to do is, first of all, we want to make sure that the user does exist, right? If he does exist, great. Then let's make sure, yes, the password is correct. And after we make sure that the password is correct, then we want to create the Jwt token and return it to the user. Okay, so if, and here we want to check if the user, so here we want to say if the user doesn't exist, then, and again for now, let's just throw an exception. Yes, okay, now in actuality, this is a bit dangerous to return because this might appear to the client that's making the request. And then if someone is just guessing emails, then over here, you can keep guessing until he guesses the correct email, and then you can go ahead and start guessing passwords. So again, this is just an intermediate implementation, and for us to be able to test it now and see that it works. Okay, next, we want to say, okay, if yes, the user is incorrect, then, okay, invalid password. If not, let's create the token. Let's say var token equals yes, generate token, and over here, let's return the actual values. So it's going to be user.id. This is going to be user.firstname. This is going to be user.lastname, email, and token. Great. So we have our application logic ready. Now let's go ahead and implement the user repository in the infrastructure layer. Okay, so let's create over here a new folder. Let's call it persistence. And let's create here the user repository implementation. Okay, this will implement the interface that we just defined. So public class user repository, yes, with a capital U, user repository. Let's implement the interface. And for now, let's just have a list. It's not thread safe. It's not the actual implementation. Again, this is just for now. Okay, so let's go ahead and say private, read only. Let's say list of users equals new. Yes. Adding will simply be users.add. And get user by email, it will be users.singular default, where the user.singular default, where, yes, the user's email is the given email. Let's return this. And that's it for now. Let's go ahead and configure this in the dependency injection IOC container. So let's say services.add. Now, one thing about this, so we define this as scoped, then it will create a new list of users for every request. So let's make this static. And let's say here add scoped. User repository, again, from the application layer, and the user repository from the infrastructure layer. Okay, this seems about right. Let's build the project and make sure that it works. Great, always fun to see. Now let's run the project. So let's run the API project. Let's make a register request. If you haven't watched the first two parts of the series, then this might seem a bit weird to you, but all this is the Visual Studio Code extension, which allows you to send HTTP requests inside Visual Studio. And we have here the response. It looks about right. Now let's make sure that when we log in, we actually get our response. So just a reminder, if we look at our API definition, then when we do login, then we pass only the email and the password, but the response contains also the first name, the last name, and the email. So if we succeeded and persisting the user in the in-memory database, then we should get these values back. So let's go ahead and make this request. And perfect, we get the values. This means that everything works as we expect. Last thing I want to do is to refactor this a bit. So let's close everything so it's a bit more organized. Over here in the authentication result, so we're returning all these values individually. This is actually just the user, right? So we can say, okay, let's just return here the user. And in the service, instead of returning it like this, you can say here user. Same goes over here. And then in the authentication controller, then instead of accessing them individually, we'll access them through the user, both here and here. And let's close this again, just so it's more organized. Over here in the Jwt Token Generator, again, we're getting here the values individually. Ideally, you'd want to get here the user, and then we can retrieve whatever values that we want to add as scopes to the token. So I'll just say here also, user. Let's go to the implementation and update this as well. So all of this we can replace with user and retrieve the values via this object. And here this is user dot capital F, user dot capital L. That should be enough. So that's it for here. Let's go to the authentication service and update this as well. So over here, let's just pass the user, both here and here. Let's run this service again. Let's make sure that this still works. Okay, so it still seems to work. Let's make the register request. And we have our response. Let's make the login request. And we get these values, which means it was persisted in our in-memory database. Okay, now, of course, we don't have any error handling. So if we try to register the same user again, then an exception is thrown, right? And with the message that we defined. And same goes if we try to make a login request with an email of someone that doesn't exist. So we'll get here the user with given email does not exist. And if we use an email that does exist, but we butcher the password, then we get this error over here. So in the future videos, we'll look into error handling. It's not part of this video. So that's it. I really hope that you like this video. Please let me know in the comments if you use the repository pattern, don't use the repository pattern. Please feel free to educate me on any topic. If you have any tips, Visual Studio Code, C#, .NET, I'd love to hear from you and learn from you as well. Okay, so that's it, and see you in the next one.